Imagine a silent invasion from the depths of space, where ancient wanderers slip into our solar system unannounced, carrying secrets from alien stars. It began in 2017, when a faint streak of light caught the eye of the Pan-STARRS telescope in Hawaii. What astronomers first thought was a routine asteroid turned out to be something unprecedented. ʻOumuamua, the first confirmed visitor from beyond our sun's grasp. Shaped like a cosmic cigar, roughly 800 feet long, it tumbled through our neighborhood at 16 miles per second, its reddish surface hinting at eons of cosmic radiation. No tail, no coma, just a mysterious rock that accelerated oddly as it left, sparking whispers of alien technology from Harvard's Avi Loeb. Then, in 2019, an amateur astronomer in Crimea spotted two I/Borisov through a homemade telescope. This one was more familiar. A comet with a glowing coma and tail, about half a mile wide, racing at 20 miles per second. Its chemistry mirrored our own comets, yet it came from afar, perhaps ejected from a distant red dwarf system. These two heralded a new era, proving our solar system isn't isolated. But the trio was incomplete. Prepare yourselves. The invasion intensifies. Fast forward to July 1st, 2025, in the arid expanses of Chile's Atacama Desert. The Atlas telescope, scanning for Earth-threatening asteroids, detected a faint dot defying the star's backdrop. Moving at an astonishing 36 miles per second, twice the speed of its predecessors. This newcomer, dubbed 3I/ATLAS or C/2025N1, shattered expectations. Unlike Oumuamua's eerie silence or Borisov's modest activity, this giant, estimated up to 12 miles across, burst to life with a vibrant coma and jets, spewing alien ices forged billions of years ago. Confirmed interstellar on July 2nd by the Minor Planet Center, it entered from Sagittarius, its hyperbolic path confirming origins in the Milky Way's ancient thick disk. Hubble's August images revealed a teardrop shape, with a nucleus alive with eruptions, rich in carbon dioxide and nickel, compositions puzzling astronomers. These three objects, arriving in just 8 years, suggest a galactic traffic we never noticed before. But why now, when our technology can finally see them? Is it coincidence, or are more on the way? Hold tight. The cosmic arrivals reveal more. The rarity of this cosmic trio is staggering. Only 3 confirmed interstellar visitors in human history, amid a galaxy of 400 billion stars constantly ejecting debris. Oumuamua, the scout, frustrated with its secrets. Borisov, the familiar comet, offered a glimpse of normalcy. Now, 3I Atlas, the colossal performer, dazzles with its activity and chemistry. Each discovery pushed our tools to the limit. Pan-STARRS for Oumuamua, an amateur's scope for Borisov, and Atlas's asteroid hunting network for the latest. Their arrivals challenge our isolation, hinting at a bustling interstellar highway where thousands pass undetected yearly. Loeb's theories fuel speculation. Oumuamua as a solar sail, Borisov as a decoy, and 3I Atlas as a probe with its precise path. These messengers carry not just ice and dust, but questions about life, technology, and our place in the cosmos. As 3I Atlas nears its solar climax, the invasion feels like a call to awaken. Picture 3 cosmic travelers, each a different beast in the vast zoo of the galaxy, One a dwarf, one a wanderer, and one a titan. The size of an interstellar object tells a saga of its birth and survival. And our trio, ʻOumuamua, 2I/Borisov, and 3I Atlas, couldn't be more different. ʻOumuamua, spotted in 2017, was a cosmic speck, just 800 feet long, like a football field tumbling through space. Its slender, cigar-like shape, measured by pan-stars, suggested a fragile fragment, perhaps chipped from a shattered world. In contrast, 2I/Borisov, found in 2019, stretched half a mile to a mile wide. A city block of ice and rock, its coma glowing with activity. Then came 3I Atlas in 2025, a true giant, estimated at 6 to 12 miles across, dwarfing its predecessors like a mountain beside pebbles. Hubble's images revealed a nucleus 1 to 3 miles wide, wrapped in a coma vast enough to swallow Earth. These sizes aren't just numbers, they hint at origins in alien systems, from tiny collisions to cataclysmic eruptions. Why such vast differences? Could 3I Atlas bulk hide something more than ice? Envision a cosmic arena where size dictates survival across the galaxy's brutal void. ʻOumuamua's petite frame, barely 800 feet long, made it a cosmic anomaly, too small to hold a coma, its reddish hue a scar from eons of radiation. Its size suggested a fragment, perhaps debris from a planet torn apart by a dying star. 2I Borisov, at half a mile to a mile wide, was more robust, its nucleus supporting a glowing coma and tail, like a typical comet but born elsewhere. Yet 3I Atlas towers over both, its 6 to 12 mile bulk a galactic titan, shielding alien ices through millions of years. Measured via Hubble and James Webb's brightness data, its nucleus alone could span a city, with a coma stretching thousands of miles. This size protected its core from interstellar erosion, unlike smaller objects that crumble. But why so massive? Was it forged in a stellar catastrophe, or, as Avilob speculates, crafted to endure as a probe? The contrast fuels debate. Small fragments like ʻOumuamua scatter easily, but 3I Atlas girth suggests intent. What kind of world births such giants? The cosmic showdown reveals more. Scale a mountain of stars to grasp why 3I Atlas size sets it apart in this cosmic trio. ʻOumuamua's 800-foot frame, too small for activity, baffled astronomers. Its survival through interstellar space, a miracle, perhaps aided by non-gravitational boosts hinting at strange physics. 2I Borisov, at a modest mile, carried enough mass to fuel a comet's classic display, its ices sublimating under our sun. But 3I Atlas, up to 12 miles wide, is a fortress of ice and rock, its nucleus erupting with jets that dwarf Earth's storms. This bulk, confirmed by 2025 telescope data, preserved exotic compounds, nickel, cyanide, through cosmic rays that shred lesser objects. Such size suggests a violent origin, like a planetary collision. Yet, its resilience sparks questions. Loeb's voice echoes. Could this be an artificial relic built to withstand the void? Scientists argue natural processes, but 3I Atlas's grandeur feels almost staged, a giant meant to dazzle. As it nears perihelion, its size fuels a data bonanza. Is it a cosmic accident or a crafted envoy? Hold tight. The giant's tale deepens. Imagine 3 cosmic racers speeding through the galaxy's endless tracks, each clocking velocities that defy our solar system's rules. The speeds of ʻOumuamua, 2. Borisov, and 3. Atlas tell tales of violent launches from alien stars. In 2017, ʻOumuamua stunned astronomers, zipping through at 16 miles per second, 57,600 miles per hour, fast enough to cross the moon's orbit in minutes. Its pace, measured by pan-stars, hinted at a forceful ejection, perhaps from a dying star's chaos. 2 years later, 2I Borisov roared in at 20 miles per second, outpacing our fastest comets, its trajectory pointing to a red dwarf's gravitational kick. But in 2025, 3I Atlas shattered all records, blazing at 36 miles per second, 130,000 miles per hour, doubling Oumuamua's speed. Atlas telescopes in Chile clocked this giant, confirming its hyperbolic path escapes our sun's grasp. Such velocity demands a cataclysmic origin, like a supernova's blast or a planetary slingshot. Why does 3I Atlas race so fiercely? Could it be more than a comet, as some whisper? The cosmic speedway reveals its secrets. Visualize a galactic highway where speed is a biography of cosmic violence. Oumuamua's 16 miles per second suggested a turbulent birth, its odd acceleration, unexplained by gravity alone, sparking Avi Loeb's talk of solar sails. 2I/Borisov's 20 miles per second, tracked by Hubble, pointed to a gentler push, perhaps a binary stars tug in a system like Kruger 60. But 3I Atlas, at 36 miles per second, is a cosmic bullet, its velocity so extreme it could cross Earth in seconds. ESA and MIT models show this speed required a colossal event, a stellar explosion or massive planet's whip, millions of years ago. Unlike its predecessors, 3I Atlas's pace sustains a vibrant coma, shedding tons of alien ice. Such energy defies natural comets, fueling speculation. Is this a probe built to sprint? Mainstream science sees a natural ejector, but the math strains belief, sustaining 130,000 miles per hour across light years demands unearthly resilience. As 3I Atlas races toward perihelion, its speed writes a story of origins. Is it a random racer or a deliberate envoy? Hold tight. The cosmic chase accelerates. Envision a comet outrunning the stars, its speed a scream across the galaxy. 3I Atlas's 36 miles per second dwarfs Oumuamua's 16 and Borisov's 20, a velocity that guarantees escape from our sun, no matter how close it swings. Backward models trace its path to Sagittarius's thick disk, a stellar nursery where chaos could launch such a speed demon. Oumuamua's pace hinted at a lightweight fragment. Borisov's suggested a typical comet. But 3I Atlas sprint, confirmed by James Webb data, implies a massive core surviving cosmic hazards, radiation, dust impacts that shred lesser objects. This velocity isn't just physics. It's a clue to a cataclysmic birth, perhaps a supernova's shockwave. Loeb's voice persists. Could such speed mark a crafted vessel, racing to deliver a message? Scientists argue natural origins, yet 3I Atlas's path, perfectly timed for our telescopes, feels staged. As it nears October 2025, its speed fuels fiery outbursts, offering a fleeting glimpse of its secrets. Is this trio's race a cosmic fluke? Or the galactic speedway unveils its truths? Picture a cosmic stage where some performers shine with fiery displays, while others slip through in eerie silence. The activity of interstellar visitors, Oumuamua, 2I/Borisov, and 3I Atlas, reveals their nature like a celestial fingerprint. In 2017, Oumuamua baffled astronomers with its stillness. Spotted by pan-stars, this 800-foot fragment showed no coma, no tail, no signs of gas or dust erupting from its reddish, cigar-shaped surface. Its silence was deafening, a rock tumbling through space with no reaction to the sun's heat, only a mysterious acceleration hinting at unseen forces. In contrast, 2I/Borisov, discovered in 2019, performed like a classic comet. Its half-mile nucleus, observed by Hubble, sprouted a glowing coma and a tail stretching thousands of miles, fueled by sublimating ices, water, carbon monoxide, typical of solar system comets. Then came 3I Atlas in 2025, a giant erupting with jets, its coma dwarfing Earth. This vibrant display, caught by James Webb, sets it apart. Why such stark contrasts? Is 3I Atlas activity a natural outburst or something more? Envision a galactic fireworks show, where one visitor stays mute while others blaze with light. ʻOumuamua's lack of activity, despite passing within 0.25 astronomical units of the Sun, puzzled scientists. No coma, no jets, just a barren surface, perhaps too small or ice-poor to react, though its odd acceleration suggested hidden outgassing. 2E Borisov, at 0.5 to 1 mile wide, lit up the sky, its nucleus spewing gas and dust as solar heat vaporized its ices. Hubble captured its coma, rich with water and carbon dioxide, extending thousands of miles with a tail shaped by solar wind. But 3I Atlas, a 6 to 12 mile giant, steals the show. Its nucleus, 1 to 3 miles wide, erupts with powerful jets, spraying tons of material hourly, as seen in 2025 telescope data. Its coma, larger than planets, glows with exotic compounds, nickel, cyanide, unlike local comets. This hyperactivity suggests a robust core, packed with volatile ices. But why so lively? Avi Loeb speculates. Could these jets be a crafted signal, not just nature's fury? The contrast raises questions about their origins. The cosmic fireworks spark deeper mysteries. Visualize a comet, painting the void with bursts of alien light, while others whisper in shadows. ʻOumuamua's silence, devoid of coma or jets, left astronomers grasping for answers. Its small size or unique composition, stifling activity, yet hinting at strange physics. 2I Borisov played a familiar tune, its coma and tail, stretching millions of miles, mirroring our comets, but born in another system. Its activity, driven by standard ices, was expected, yet thrilling. 3I Atlas, however, is a cosmic volcano. James Webb's 2025 images show its nucleus erupting with jets, spinning to create spiral patterns in a coma vast enough to eclipse Earth. These outbursts, rich with carbon dioxide and organics, suggest a core packed with alien chemistry, preserved through eons. Why such a vivid display? Loeb's theory looms. Could 3I Atlas's jets be engineered? A beacon for our telescopes? Scientists see natural sublimation, but its intensity feels staged. As perihelion nears, these jets offer a fleeting chance to decode its story. Is this trio's contrast mere chance or a cosmic message? Prepare yourselves. The cosmic stage dazzles. Imagine cracking open a vial of stardust, each molecule a fingerprint from an alien world. The chemistry of ʻOumuamua, 2I Borisov, and 3I Atlas offers clues to their distant births, like pages from a cosmic recipe book. In 2017, ʻOumuamua was a chemical ghost. Its 800-foot frame showed no coma, no gas emissions, leaving telescopes like pan-stars grasping at shadows. Its reddish hue suggested organic rich crust, battered by cosmic rays, but no direct samples emerged, fueling mystery. In 2019, Borisov played a familiar tune, its coma revealing water, carbon monoxide, and cyanogen, akin to solar system comets. Hubble's spectroscopes confirmed a standard mix, hinting at a red dwarf origin. Then, in 2025, 3I Atlas burst onto the scene, its massive coma glowing with exotic signals. James Webb detected high carbon dioxide, 8 times more than typical comets, plus nickel and cyanide, compounds rare in our system. These chemicals, preserved in its 12-mile wide core, point to a unique birthplace. Are they natural or something crafted? Prepare yourselves. The cosmic chemistry unveils its secrets. Picture a cosmic lab where alien worlds leave their chemical calling cards. ʻOumuamua's silence frustrated scientists. Its lack of outgassing meant no direct chemical data, only hints of organic molecules from its red, irradiated surface. Was it a barren rock or hiding complex ices? 2I Borisov, by contrast, was an open book. Its coma, stretching thousands of miles, released water, carbon dioxide, and traces of ammonia, mirroring our comets, but forged elsewhere, perhaps in a system like Kruger 60. Spectroscopes pinned its chemistry as familiar, yet alien in origin. 3I Atlas, however, is a chemical enigma. Its 2025 data, captured by Keck and James Webb, shows a carbon dioxide to water ratio of 8 with an uncertainty of 1, among the highest ever, with nickel and cyanide adding an exotic twist. These compounds, preserved through eons, suggest a birthplace near a massive star or supernova remnant. Why such a unique mix? Avi Loeb speculates, could this be a synthetic payload, not just a comet? The trio's chemical contrast raises questions about their formation. Are these natural recipes or a cosmic code? The alien fingerprints deepen the mystery. Envision a comet spilling secrets from a star we'll never see, its chemistry a blueprint of alien worlds. ʻOumuamua's mute surface offered only guesses, organic crust, perhaps, but no gas to analyze, leaving its story locked away. 2I Borisov was transparent, its coma and tail rich with water, carbon monoxide, and cyanogen, suggesting a formation in a cold, distant disk, much like our own comets. But 3I Atlas is a chemical spectacle, its massive nucleus erupting with jets that spray carbon dioxide, nickel, and cyanide, compounds rare in our solar system. These molecules, caught by 2025 spectroscopes, survived millions of years in the void, shielded by a core up to 12 miles wide. Such preservation hints at a turbulent origin, perhaps a supernova's chemical forge. Yet, the clarity of 3I Atlas's emissions feels almost curated. Loeb's theory lingers. Could this be an artificial archive, broadcast in alien chemistry? Scientists see a natural comet, but its exotic makeup challenges assumptions. As perihelion nears, these clues offer a fleeting chance to decode the trio's origins. Are they random relics, or signals from the stars? The cosmic chemistry sparks wonder. Imagine 3 cosmic arrows piercing our solar system, each following a path that defies expectations and hints at hidden designs. The orbits of ʻOumuamua, 2E/Borisov, and 3I Atlas are galactic riddles, their trajectories weaving through our planets like threads in a cosmic tapestry. In 2017, ʻOumuamua entered from the direction of Lyra, tumbling on a hyperbolic path with an eccentricity of 1.2. barely interstellar, yet unbound by our Sun. It grazed within 0.25 astronomical units, slingshotting out with odd acceleration, as if nudged by invisible forces. In 2019, two I/Borisov arrived from Cassiopeia, its eccentricity 3.4, carving a more open curve, passing 2 astronomical units at closest, its tail streaming like a comet's banner. But in 2025, 3 I-Atlas sliced in from Sagittarius, its eccentricity a record 6.14, the most hyperbolic yet. This path threads past Venus, Mars, and Jupiter at perfect viewing distances, reaching 1.4 astronomical units at perihelion in October. Why such precision? Avi Loeb speculates. Could 3 I-Atlas's route be engineered? The cosmic roots begin to twist. Visualize a galactic labyrinth where paths reveal origins and intent. Oumuamua's orbit was chaotic, its tumbling motion spinning every 7.4 hours, suggesting a violent ejection, perhaps from a star like Vega. Its close solar pass, 0.25 astronomical units, should have triggered activity, yet it remained silent, its path a riddle. 2 I/Borisov's trajectory was smoother, eccentricity 3.4 allowing a 2 AU perihelion. Its path pointed to a red dwarf like Kruger 60. Hubble tracked its curve, a classic cometary arc with a tail aligned by solar wind. 3 I-Atlas, however, is an orbital marvel. Eccentricity 6.14 ensures a swift escape, its path from Sagittarius's thick disk threading our system with eerie accuracy. James Webb models show it skirting planets for optimal observation, timed for autumn 2025. This alignment defies odds, as if choreographed. Loeb's theory stirs. A natural comet wouldn't pick such a route. Could it be a probe scouting? Scientists cite gravitational chaos, but 3 I-Atlas's precision nags. Are these paths random or guided? The cosmic labyrinth deepens its enigmas. Envision a comet's path as a cosmic signature, etched across our skies. Oumuamua's hyperbolic arc, entering at 16 miles per second, was a fleeting visit, its tumble hinting at a shattered past. Backward projections suggest a launch millions of years ago, dodging stars en route. 2 I/Borisov's path at 20 miles per second was a gentle curve, its 2 AU perihelion allowing months of study, tracing to a binary system. But 3 I-Atlas's orbit is a masterpiece, 36 miles per second, eccentricity 6.14, a arrow straight from the galaxy's heart. Its 1.4 astronomical units closest approach in October 2025 offers prime viewing, as if intended. ESA simulations show it navigated gravitational fields with improbable grace. Why this route? Loeb posits, a crafted vessel wouldn't wander blindly. Mainstream views see chance, but the trio's contrasts, chaotic, smooth, precise, spark doubt. As 3 I-Atlas nears, its path promises revelations before escape. Are these oddities flukes or invitations from the stars? The cosmic signatures whisper their truths. Imagine tracing cosmic breadcrumbs back through billions of years, unraveling the birthplaces of 3 interstellar wanderers. The origins of Oumuamua, 2 I/Borisov, and 3 I-Atlas are galactic puzzles, each path a clue to alien stars. In 2017, Oumuamua's backward trajectory pointed to the constellation Lyra, suggesting a launch from a young, thin disk star system, perhaps a Pluto-like world shattered by gravitational chaos. Pan-STARRS data hinted at a billion-year journey, its low velocity implying a nearby origin with heavy elements. In 2019, I/Borisov's path traced to Cassiopeia, possibly the red dwarf binary Kruger-60, ejected from its outer fringes where carbon monoxide froze in abundance. Hubble confirmed its cold, distant birth, akin to our Oort cloud. But in 2025, 3I Atlas emerged from Sagittarius, its trajectory routing in the Milky Way's ancient thick disk, home to stars over 7 billion years old. Atlas telescopes in Chile revealed a median kinematic age of 0.8 billion years for its journey, suggesting a turbulent stellar nursery. Why these diverse cradles? Avi Loeb speculates, could 3I Atlas hail from a crafted source? The cosmic births begin to emerge. Envision stellar nurseries across the galaxy, birthing these interstellar nomads in fiery cataclysms. Oumuamua's origin remains elusive, its path from Lyra suggesting a thin disk star, perhaps Vega-like, where a planetary collision flung it free a billion years ago. Its composition, guessed at organic-rich, hints at a system with heavy elements, as ASU scientists proposed. 2I/Borisov's trail led to Kruger-60, a red dwarf binary, its high carbon monoxide pointing to formation in a cold outer disk, ejected by gravitational tugs 1.7 billion years back. ALMA observations confirmed its pristine, comet-like makeup, mirroring our early solar system. 3I Atlas, however, traces to the thick disk's older realm, a 7 billion-year-old environment of ancient stars, its 0.8 billion-year journey suggesting a supernova or massive stars blast. Gemini North data shows its exotic chemistry, high CO2, nickel, fitting a turbulent birthplace. These origins contrast young chaos for Oumuamua, cold stability for Borisov, ancient violence for 3I Atlas. Loeb's voice echoes, could 3I Atlas be artificial, from a civilization's remnants? The galactic cradles stir deeper questions. Picture ancient stars forging these visitors in cosmic fires, their paths converging on our sun. Oumuamua's Lyra origin, a billion years distant, implies a thin disk ejection, perhaps from a Pluto analog, as UChicago models suggest. Its silence and shape fuel Loeb's probe theory. 2I/Borisov's Kruger-60 roots 1.7 billion years ago point to a red dwarf's outer edge, its chemistry, water, cyanogen, preserved like a time capsule, as ESO and Noyalab noted. 3I Atlas's Sagittarius trail from the thick disk's 7 billion-year-old stars suggests a 0.8 billion-year voyage from a supernova remnant, its high CO2 ratio hinting at explosive formation. SphereX and JWST data confirm its pristine exotic makeup. These diverse births, fragmented world, cold comet, ancient giant, challenge models. Why do they reach us now? Loeb posits, natural relics or deliberate scouts. Scientists see galactic debris, but the trio's timing nags. As 3I Atlas nears perihelion, its origins promise revelations. Are they random exiles or messengers from lost stars? The cosmic sources whisper their tales. Picture 3 cosmic survivors braving a galactic gauntlet, where radiation and darkness shred the weak. The endurance of Oumuamua, 2I Borisov, and 3I Atlas against interstellar odds is a testament to their resilience. In 2017, ʻOumuamua crossed light years, its 800-foot frame battered by cosmic rays that turned its surface red. Yet it emerged intact, perhaps due to a tough organic crust or exotic ices like hydrogen. No activity meant no mass loss, a silent strategy for survival. In 2019, 2I Borisov endured similar perils, its half-mile nucleus shielded by layers of water and carbon ices, preserving chemistry through eons of cold near absolute zero. Hubble noted its coma formed only near our Sun, suggesting a dormant core that withstood micro-impacts. But in 2025, 3I Atlas, a 12-mile giant, defied the void's assault. Its massive core protecting volatile compounds from radiation that breaks molecules. James Webb data shows minimal erosion, hinting at a fortified structure. Why such varying endurance? A.V. Loeb wonders, could 3I Atlas be built to last? The cosmic trials begin to test their mettle. Envision a void where tiny dust grains strike like bullets and temperatures plunge to near nothingness. Oumuamua's survival was a puzzle. Its small size should have made it vulnerable to cosmic rays ionizing its surface. Yet it arrived with shape intact, perhaps nitrogen ice or a pancake form reducing exposure. Its billion-year trek demanded luck or design. 2I Borisov fared through similar hazards, its icy mantle absorbing radiation, preserving cyanogen and water for 1.7 billion years. ALMA observations suggest its composition mimicked resilient Oort cloud objects, dodging collisions in the sparse interstellar medium. 3I Atlas, however, is a fortress. Its 12-mile bulk shielded inner ices from erosion, surviving 0.8 billion years with high CO2 intact. Gemini North data reveals daughter molecules from ray interactions, timestamps of its journey. This robustness contrasts sharply. Small ʻOumuamua's stealth, Borisov's standard shield, 3I Atlas's giant armor. Loeb speculates a natural comet or engineered to endure. Scientists see evolutionary odds, but 3I Atlas's odds defying state intrigues. Hold tight. The cosmic endurance deepens. Visualize interstellar space as a relentless storm, where survival is a miracle of matter. Oumuamua braved it with minimal scars, its possible hydrogen outgassing providing thrust as Loeb proposed, enduring eons without crumbling. 2I Borisov's journey preserved its cometary ices, its size allowing internal heat pockets to fend off absolute zero's brittleness. ESO studies show it resisted dust impacts that could fracture lesser bodies. 3I Atlas, a titan, conquered the void's trials, cosmic rays creating a protective crust, its mass deflecting micrometeors. JWST reveals radiation-altered organics, proof of its 0.8 billion-year odyssey from an ancient disk. These strategies vary. Oumuamua's subtlety, Borisov's balance. 3I Atlas's sheer power. Why did 3I Atlas arrive so pristine? Loeb's theory, perhaps a crafted survivor, sent to test our gaze. Scientists argue natural selection in stellar ejections. As perihelion tests 3I Atlas further, its odds-beating story challenges us. Are they lucky drifters or purposeful voyagers? The cosmic odds stack higher. Imagine a cosmic signal flashing across the stars. Not a comet, but a probe from an alien mind. Harvard's A.V. Loeb ignited a firestorm in 2017, suggesting Oumuamua wasn't a rock, but a possible artifact. A solar sail, perhaps, sent to scout our system. Its odd acceleration, defying gravity alone, and cigar-like shape fueled his claim, as no natural comet moves without visible outgassing. In 2019, 2I/Borisov calmed the debate, its familiar coma and tail. Water, cyanogen, marking it as a standard comet, likely from a red dwarf like Kruger 60. But in 2025, 3I Atlas reignited the controversy. Its massive size, high CO2, and precise path, caught by ATLAS telescopes, prompted Loeb to double down. Could this 12-mile giant be a crafted beacon? Its vibrant jets and exotic chemistry, unlike Borisov's norms, seem almost performative. Mainstream scientists scoffed, citing natural origins for ʻOumuamua's boost and 3I Atlas activity. Yet Loeb's ideas challenge our assumptions. Are these visitors mere rocks or something sent? Prepare yourselves. The cosmic debate ignites. Picture a galactic courtroom where science and speculation clash over 3 cosmic travelers. Loeb's 2018 paper on ʻOumuamua proposed it could be a thin, light sail, its non-gravitational acceleration, 0.1 micrometers per second squared, suggesting artificial propulsion. Its 800-foot shape and silence defied comet norms, sparking theories of alien tech. 2I Borisov, however, was a rebuttal. Its 0.5-mile nucleus, spewing water and CO, fit natural comet models, as Hubble data confirmed, dampening probe torque. 3I Atlas in 2025 revived the fire. Its 6 to 12 mile size, high CO, 2 to water ratio, 8 with an uncertainty of 1 and precise trajectory, per James Webb, seem too perfect. Loeb argues its jets and path could signal a probe designed to dazzle our telescopes. Critics counter with physics ʻOumuamua's boost from unseen gas, 3I Atlas activity from solar heat. Yet, the trio's timing, 3 in 8 years, nags at coincidence. Why now, when we can see them? Loeb's voice persists, natural relics or a galactic message. The cosmic trial probes deeper truths. Envision a cosmos where every comet could hide a purpose, a design we're only beginning to grasp. Loeb's hypothesis on ʻOumuamua leaned on its anomalies, no coma, yet accelerating, possibly a defunct probe from a Lyra-like star. 2I Borisov countered the debate, its familiar chemistry and activity, seen by ALMA, screaming natural comet from a red dwarf's edge. But 3I Atlas, with its city-sized nucleus and vibrant jets, fuels Loeb's boldest claims. Its 2025 data, nickel, cyanide, and a path threading our planets, suggests intent, as if meant to be seen. Loeb posits it could be a functional craft, its chemistry a coded signal. Scientists, backed by ESO and Gemini North, argue its outbursts are solar-driven, its path a lucky alignment. The trio's contrast, silent, standard, spectacular, sharpens the debate. Why do ʻOumuamua and 3I Atlas defy norms, while Borisov conforms? As 3I Atlas nears perihelion, its fleeting show challenges our solitude. Are they random or part of an alien plan? The cosmic questions burn brighter. Picture peering through cosmic lenses, capturing snapshots of alien worlds racing by. The telescopic views of ʻOumuamua, 2I Borisov, and 3I Atlas reveal structural secrets that challenge our understanding. In 2017, pan-stars in Hawaii first spotted ʻOumuamua as a faint streak, its 800-foot cigar-like form tumbling erratically. Hubble's follow-up images showed a reddish, elongated body with no coma, just a barren surface scarred by eons. Its shape, perhaps flat like a pancake, hinted at exotic origins. In 2019, 2E Borisov appeared as a glowing dot to an amateur's scope, but Hubble unveiled a classic comet, a nucleus wrapped in a fuzzy coma, tail streaming millions of miles. Its structure mirrored our comets, with dust jets suggesting a porous core. Then, in 2025, 3I Atlas dazzled with James Webb's infrared gaze, revealing a teardrop coma vast as Earth, nucleus erupting with jets. This 12-mile giant's details, spiral patterns, exotic glow, set it apart. Why such visual contrasts? Avi Loeb speculates, could 3I Atlas's spectacle be designed? The cosmic portraits begin to sharpen. Envision telescopes as cosmic detectives, unveiling hidden forms in the void. Pan-STARRS images of ʻOumuamua captured a tumbling enigma, its light curve suggesting a 10:1 elongation. Reddish hue from radiation-baked organics. No dust trails, just a silent wanderer. Hubble's deeper look confirmed no activity, its structure a puzzle, rock or ice shard. 2I Borisov's Hubble portraits showed a dynamic comet, coma enveloping a half-mile nucleus, tail with blue gas and yellow dust. Its jets, faint but present, revealed a layered interior, much like Halley's Comet. 3I Atlas, through James Webb's 2025 lenses, is a masterpiece. A glowing teardrop, nucleus spinning with powerful jets spraying cyanide-laced gas. Its coma, thousands of miles wide, pulses with spirals, hinting at a robust city-sized core. These revelations contrast ʻOumuamua's barrenness, Borisov's familiarity, 3I Atlas's vibrancy. Loeb's theory stirs. A natural display or a staged show? Scientists see solar-driven evolution, but 3I Atlas's clarity feels curated. The cosmic detectives probe further mysteries. Visualize stellar snapshots that rewrite the stars' stories, each frame a clue to alien realms. Hubble's final ʻOumuamua images, as it faded, showed a featureless form, its tumble hiding details, perhaps a thin disk or fragment. No jets, no coma. A stealthy visitor. For 2I Borisov, Hubble and VLT captured a lively structure. Coma with dust grains, tail bifurcated by wind, nucleus porous like a sponge. Its revelations confirmed a standard comet, born cold. 3I Atlas's James. Webb views stun. A nucleus alive with jets, coma asymmetric from solar pressure, spirals from spin. Its 1 to 3 mile core, erupting organics, suggests preserved alien layers. These images highlight odds. ʻOumuamua's minimalism, Borisov's textbook form, 3I Atlas's grandeur. Why does 3I Atlas pose so vividly? Loeb posits, an artifact meant to be seen. Scientists argue observational bias, but the trio's visuals spark doubt. As perihelion looms for 3I Atlas, these revelations offer fleeting insights. Are they random snapshots or intentional portraits? The cosmic gallery whispers its enigmas. Picture a world gripped by cosmic fever, as a mysterious object sparks headlines and dreams of alien contact. When ʻOumuamua streaked through in 2017, it ignited a global frenzy. Detected by Pan-STARRS, its odd shape and acceleration fueled viral stories, from tabloid claims of UFOs to Harvard's Avi Loeb suggesting a solar sail. Social media buzzed with memes, X-posts calling it a space cigar, and sci-fi fans speculating about probes. In 2019, 2I/Borisov's arrival was less sensational, but still captivating. Its familiar cometary glow, spotted by an amateur in Crimea, inspired awe, with ex-users sharing telescope photos and astronomers on TV explaining its red dwarf origins. The public embraced it as a cosmic cousin, less alien than ʻOumuamua. Then, in 2025, 3I Atlas exploded onto the scene, its 12-mile size and vibrant jets dominating news. X erupted with number 3I Atlas. Artists sketched its glowing coma, and talk shows debated Loeb's probe theories. Each object stirred humanity's imagination, blending science with wonder. Why do these visitors captivate us so? The cosmic spotlight shines on our reactions. Envision a planet united by starlit questions, as each interstellar visitor reshapes our cultural lens. ʻOumuamua's 2017 discovery sparked academic debates and pop culture mania. Loeb's alien tech hypothesis hit journals, while X posts exploded with first contact, hashtags, and movies like Interstellar. Saw streaming spikes. Its mystery drove podcasts, with millions pondering its silent flight. 2. Borisov's 2019. Arrival was calmer, its comet-like traits reassuring but thrilling. Amateur astronomers shared images on X, schools taught its chemistry, and space blogs compared it to Halley's Comet. Its familiarity grounded the hype, yet still inspired art and music. 3. Atlas, in 2025, became a global obsession. Its massive coma and exotic jets, captured by James Webb, flooded X with videos, while news outlets ran alien or comet. Polls. Loeb's renewed probe claims fueled TED Talks and late-night shows. The trio's impact varies. ʻOumuamua's enigma, Borisov's relatability, 3I Atlas spectacle. Why does 3I Atlas grip us most? Is it just its size or a deeper pull? Humanity's fascination grows louder. Visualize humanity staring skyward as 3 cosmic messengers rewrite our stories and fears. ʻOumuamua's 2017 passage left a lasting mark. Loeb's book, Extraterrestrial, sold millions. X debates raged over its origins, and sci-fi novels surged. It challenged our cosmic loneliness. 2I/Borisov, in 2019, brought a softer awe, its comet-like glow sparking stargazing events and X threads on alien chemistry. Schools named clubs after it, and artists painted its tale. 3I Atlas, in 2025, unleashed a cultural storm. Its vibrant jets and size, seen by Hubble, inspired viral X challenges like #Spot3I Atlas, while documentaries and TikToks speculated on alien signals. Loeb's probe theories trended, countered by NASA's natural explanations, yet public curiosity soared. The trio reshapes us. ʻOumuamua's mystery stirred doubt. Borisov's familiarity calmed. 3I Atlas grandeur excites. As it nears perihelion, humanity wonders, are these random rocks or a call to look up? The cosmic impact echoes in our dreams. Picture a cosmic highway bustling with unseen travelers as humanity gears up to spot the next galactic visitor. The arrivals of ʻOumuamua, 2I Borisov, and 3I Atlas, 3 in 8 years, hint at a galaxy teeming with interstellar objects. Astronomers estimate thousands pass through our solar system annually, most too faint for current telescopes. The Vera C. Rubin Observatory, launching in 2025, promises to change that, its deep sky scans potentially spotting dozens yearly. ʻOumuamua's faint streak required Pan-STARRS' luck. Borisov relied on an amateur's scope. 3I Atlas, caught by Atlas in 2025, dazzled with its 12-mile coma. But future detections need sharper tools. Missions like ESA's, JUICE or NASA's, PSYCHE, passing near 3I Atlas's path in 2026 at 0.33 AU, could pivot for flybys, imaging its nucleus or sampling its jets. Such data could decode its alien chemistry, nickel, cyanide, or test Loeb's probe theory. What will we find next? Are more giants like 3I Atlas coming, or silent scouts like ʻOumuamua? The cosmic highway hums with possibilities. Envision a fleet of spacecraft chasing cosmic ghosts, racing to catch a fading interstellar star. The trio, ʻOumuamua, 2, Borisov, 3, I Atlas, slipped by too fast for close study, but future missions could change that. The Comet Interceptor, planned for 2029 by ESA, aims to rendezvous with an interstellar object, equipped to analyze coma gases or surface ices. 3. I Atlas, at 36 miles per second, may elude such plans, but its 2026 proximity to JUICE's path offers hope. A flyby could reveal its nucleus's structure, rocky or layered, or confirm its high CO2 ratio. Scientists dream of sampling its jets, rich with alien organics, to compare with Borisov's familiar water or ʻOumuamua's silent crust. Meanwhile, AI-driven surveys like those at Caltech predict a surge in detections by 2030, as telescopes like Spherex scan infrared skies. Loeb's voice persists. What if the next visitor is a probe, signaling intent? Critics argue natural debris dominates, but the trio's timing suggests otherwise. Will we be ready for the next visitor, or miss another clue? The cosmic chase gears up. Visualize humanity on the brink of a cosmic awakening, as the stars send more messengers our way. The trio's fleeting visits, ʻOumuamua's silent sprint, Borisov's glowing tail, 3I Atlas's vibrant jets, hint at a galaxy alive with wanderers. The Rubin Observatory's 2025 debut could spot objects as faint as magnitude 24, revealing hundreds yearly. Missions like Comet Interceptor or a redirected Psyche could chase 3I Atlas, probing its alien chemistry or testing Loeb's artificial origin theory. Success would rewrite science, confirming natural comets, or, daringly, something crafted. X-posts already buzz with Interstellar Watch, as enthusiasts and scientists speculate. Are these visitors random, or part of a pattern? The trio's arrivals, perfectly timed for our tech, fuel Loeb's dark forest idea, civilizations signaling cautiously. As 3I Atlas nears perihelion in October 2025, our last chance to study it looms. What will the next visitor bring? Ice, rock, or a message? The cosmic future beckons with promise. Picture: humanity gazing into a cosmic mirror, reflecting our place among the stars. The journeys of ʻOumuamua, 2 I Borisov, and 3I Atlas, 3 interstellar visitors, have reshaped our dreams and fears. From ʻOumuamua's silent mystery to Borisov's familiar glow, and 3I Atlas's blazing jets, they carry secrets of alien worlds, sparking wonder and debate. Are they mere comets or signals from distant minds? Their fleeting visits, perfectly timed for our telescopes, challenge our solitude. Cosmic depth will chase these mysteries, unraveling the galaxy's whispers. Subscribe to join the quest as we seek the next visitor and our place in the cosmos. The legacy endures. urging us to look up.